Hello students, in today's class we are going to discuss about the four topics from the chapter 1 number systems of grade 9 maths. So first is decimal expansion of rational numbers, then next conversion of recurring decimal number into p by q form, thirdly representation of decimal number on number line, and fourthly representation of square root of decimal number, for example root over 5.6 on the number line. To discuss on the first topic, that is decimal expansion of rational numbers, let us take some example. Let us take these rational numbers 3 by 2, 3 by 5, 7 by 8 and 7 by 25, and then if we divide 3 by 2, then what we'll get? We'll get 1.5. Next, similarly here also, so this will be 0.6, this is 0.875 and this one is 0.28. So you can see all these rational numbers, if we divide, then we get terminating decimal numbers. Everywhere we can get terminating decimal numbers. Now along with this, let us take few more examples. Say 1 by 3 and 2 by 7. So if we divide 1 by 3, then we get 0.333, which is equals to 0.3 bar. Then this is, we get 0.285,714 bar. That means these digits will keep on repeating. Now if we see the difference between these numbers and these numbers, then we'll get to know that the simplest form of the rational numbers here in everywhere, the denominators are either 2 or 5, or maybe multiple of 2 or maybe multiple of 5, or maybe combination of 2 and 5 here. And here we will get the denominator in the simplified form of the rational number are other than 2 and 5. Here it is 3, here it is 7. So the difference is, if the denominators are of the form 2 to the power m and 5 to the power n, where m and n are some whole numbers, so it can be 2 to the power 0 into 5 to the power 2, it can be 2 to the power 3 into 5 to the power 0, it can be 2 to the power 3 into 5 to the power 1, something like this. So then in this case, if the denominators are of this type, then we will get terminating decimal numbers. So from these examples, we can identify the terminating decimal numbers and non-terminating recurring decimal numbers. Now next thing is, without dividing, how can we represent these terminating decimal numbers to decimal form? So for this, let us see what we'll have to do. In the rational number, we'll see the denominator, and the denominator we'll have to convert to the form of 2 to the power 5 m into 5 to the power n. So here we have only 1 2. So as many number of 2's are there, we'll have to multiply it by that many 5 in numerator and denominator. So then this will become 15 by 10, and then now we can write it easily. It is 1.5 because below it is 10 and we have 1 0, so it becomes 1.5. So similarly, take the next one. Here it is 3 by 5, so we'll multiply. We have 1 5 here, so we'll multiply with 1 to numerator and denominator. So basically we have to make the number of 2 and number of 5 same in the denominator. So as per requirement, we'll have to multiply that much 2 or that much 5. So here this will become 6 by 10, and then answer will become 0.6, the decimal before one digit. You can see the next number. Here it is 7 by 8. So 7 by 8 means 7 by 2 to the power 3. So then how many 5 will multiply? Because we have 3 2 here, so we'll have to multiply by 3 5. That means 5 cube, and in numerator also 5 cube. So then this will become 1000, because 2 5 is a 10 10 10, and we'll have 3 10 multiplied, so it is 1000. And here this side, this will become 5 cube, that means 125, and multiplied by 7, it will become 875. So, and then the answer would be 0.875, because we have 1 and 3 0, so decimal will have to put before 3 digits, so it becomes 0.875. Similarly, the next one, 7 by 25. So 7 by 25 means we can write it as 7 into 5 square. So obviously we will have to multiply by 2 square and 2 square. So always we will have to see the number of 5 and number of 2 equal in the denominator, and accordingly we will multiply in numerator also. So this will become 100, and in numerator will be 2 is a 4, 4 7 is a 28, and then the answer would be 0.28. Next we'll learn about the conversion of recurring decimal into p by q form. So for this we have taken 3 examples. Number 1, 2.3 bar. Here 3 will repeat, so it is 2.3333 like this. Here it is second example, 21.57 bar, so 5 7 will keep on repeating. So here third example I have taken 6.3521, and bar is above 521, so this 521 will keep on repeating. So this we will see how we can convert to p by q form. So let us take the first example. First we will assume as the given number with x. Let x equals to 2.3 bar, that means 333. 3 will keep on repeating. Then next we will have to see here only one digit is repeating after decimal, so we will multiply both sides of this equation by 10. Remember, one digit means we will multiply by 10. Here in the second example, two digits are repeating, so in the second step of this sum we will multiply both sides by 100, that is 1 and 2 0. Here you can see in the third example 3 digits will repeat after decimal, so we'll multiply both sides in the second step by 1 and 3 0, that is 1000. That much only we have to remember. So 1 digit will repeat means multiply by 10, 2 digit will repeat means multiply by 100, and 3 digit repeats means multiply by 1000, and then we'll follow the next steps. So here 1 digits are repeating, so multiply it by 10. 10x equals to 10 into 2.333. This will become 23.333. Because we are multiplying by 10, so decimal will go after one digit here, so it becomes 23.333. so it is 10x equal to this. So in the earlier steps we can mark it as equation 1, and here this step we can mark it as equation 2. Now below this step we'll write the equation 1 once again, and then we'll subtract it from the equation 2. So we'll write equation 1 here below the equation 2, and then we'll subtract. This is 10x, this is 1x, so 10x minus 1x will become 9x, and that is equals to, here we have written the right hand side of equation 1 such a way that the decimal should be in the same line, and then right hand side will subtract. Everywhere here it is same, 3 3 3, because infinite numbers of 3s are there, here also infinite number of 3, so this will become 0. And then here 23 minus 2, this will become 21, so it is 21.0. so here x will be 21 divided by 9. 21.0 means 21 and divided by 9. And if possible we will write in simplest form. Okay, we can cancel 21 and 9 by 3, so 3 7s are 21, 3 3s are 9, and x we assume this as 2.333, that is 2.3 bar that we have written here. So therefore 2.3 bar is 7 by 3. We had to convert this to p by q form, so this is the answer. So I have shown here second and third also. Second, it was given 21.57 bar, so 57 was repeating, so 2 digits was repeating, so we have assumed this as x 5757, then both sides we have multiplied by 100 because 2 digit was repeating. And then equation 1 we have subtract from this, you can see 100x minus 1x 99x, and then after decimal the digits are same, so it becomes 0, so 2136. Then we have divide this by 99. 99 will shift, so x will be this one. If possible we'll simplify, so after simplifying we'll get this much, cancelling both numerator and denominator by 3. So then therefore 21.57 bar is 712 divided by 33. Similarly the third example, 3 digit was repeating, we have assumed this as x 6.3521521, and both side we have multiplied by 1 and 3 0, that is 1000, and then decimal will shift after 3 digit, so this will come 6352.152152 and so on. Then equation 1 we have written here again, subtract 1000x minus 1x is 999x, which is equals to, now see here decimal below decimal, so from the second digit they are equal, 521 521, that will be equal, so that will become 0, but this after decimal this 3 we have to subtract from 1, so we'll take 1 from here, carry over 11 minus 3 8, and 1 left here, then again 1 carry, 11 minus 6 5, and then 634, so 6345.8. Next step 999, shift right hand side, so as we have one digit after decimal, so multiply both numerator and denominator by 10, so then decimal will go, this will left, we can cancel this by 2, and then the final answer is this. So we have converted 6.3521 bar into p by q form. Next we learn how to represent decimal number on the number line using successive magnification. So we have taken two examples. so 2.57, and second one is 3.293. So in the first example 2.57, so to represent this we have drawn a number line. Here it is 0, 1, 2, 3, 4 and so on. Left side we have -1, -2, so that we will draw with equal gap. So this is our number line. Here we need to represent 2.57. So students, we can see to represent 2.57 in a number line, this is not possible, because if we need to represent 2.57 in the same line, then between each number we'll have to make 100 division, which is not possible here. So that is why we'll use this successive magnification. So see the process how we go. First, as the number is 2.57, so obviously it will be in between 2 and 3. So first we'll have to expand this point from 2 up to 3 using 10-point scale. So let us see how we expand this. So here we have drawn one line from 2, and this is the point 2, and this another line we have drawn. So actually this gap 2, 3 we have to expand from here to here. Now here we have written 2, and this side we will have to write 3. But before writing 3, first we will have to make 10 equal division in this line. Using scale we have made 10 equal division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this 10th point will be our 3. Now we'll join this point and this point. So we'll expand this to 3 to this much point. This is 2, and then this will be 2.1, 2.2 and so on, 2.9, and this is 3, that is 3.0. Now our question was 2.57, so here you can see 2.5, and obviously 2.57 is in between 2.5 and 2.6. So now next we'll have to expand 2.5 and 2.6 in the same way. First we'll draw one line from here 2.5, then we'll draw another line, and here we'll make 10 equal division. In the 10th division we'll join with 2.6. So here you can see 2.5 we have expanded here, and then we have made 10 equal division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and in the 10th point we have to join with 2.6. So our question was 2.57, so after decimal 2 digit, so we have to expand it twice, and then we'll get the place of this number, and here we can see the place 2.57, this is the place, and then we'll mark here by pencil, and that would be our representation. Next example is of 3 places of decimal. So here we'll have to repeat this step once again. So first once we'll do it for 3.2, then next step will be 4.29, and one more step we'll have to expand. So this you will do yourself. Instead of this we are taking one different example, which is recurring decimal number. For this kind of question, up to how many places we'll have to represent, that will be given in question. So here it is given, represent 4.23 bar up to 4 places of decimal. So we'll have to represent only up to here 2, 3, 2, 3, 1, 2, 3, 4, 4 place. Till here we'll have to represent. So it means we'll have to draw 4 steps. So as it is 4 point something, so we'll have to expand 4 and 5 as earlier process. So first step is done, then 4.1, 4.2, 4.3. So 4.2 we have got. then this 4.2 will expand. We'll draw this line, then we will make 10 division. In the 10th place we will join with this one. 4.23 we have got here. Then to get the next step, this 4.23 will have to expand. Draw this line, make 10 equal division. In the 10th place join with 4.24. Then again 4.23 and 4.24 we have 10 division, so 4.231, 4.232, then 4.233. so this 4.232 will have to expand. Draw this line, then this will be your 4.232, and then make 10 equal division, and this 10th position join with this. So this is your 4.232. then in the 10th position 4.233. now this point will be 4.2321, and this is 4.2322. this one will be 4.2323, and next will be 4.2324. now so it will go like this. Now as we have to represent 4.23 bar up to 4 places of decimal, so in the 4th step we'll have to stop and we'll have to see. Now this is 4.2323 and this is 4.2324. if we need to represent up to 5 place, so this 4.2323 and 4.2324 will have to expand. So our required number will be somewhere here in between these two number. So like this we will have to mark, because our number would be in between this, and that would be our representation. Next we learn how to represent root over 5.6 on the number line. So for this, first we'll draw the number line, then we'll draw perpendicular at some point in between, and then this we have marked as O. Now in the right hand side of this point O, we'll mark in 1 unit. So this 1 unit can be 1 centimeter also, it can be 1 inch also. And left hand side will mark at the point where it is 5.6 unit. So whatever unit we'll take in right hand side, same unit we'll have to take left hand side. So here I have taken centimeter, so from O right hand side I have taken 1 centimeter, so mark it as A, and from O left hand side we have marked here, taken 1 point which is B, where OB is 5.6. so now we have to remember that OA is always same, so everywhere we'll have to take 1 unit here right side, so that will be equal, but this place of B will differ depending upon this question. So here it is 5.6, so from O will measure 5.6. if it is 9.1, from here we will measure 9.1. if it is 8.6, from here we will measure 8.6 and mark B accordingly. So now after this the steps are same for all type of this question. We'll take compass and we have to find midpoint of A and B. So for this, taking compass, take more than half of this AB and draw arc both side of this line. Here also one arc and opposite side also the another arc, and in the same arc length from B also you have to draw this. So from B we have drawn this, one's from A and one's from B. So the arc will cut each other. Now with the help of scale we have to join these two point of intersection of these two arcs from this up to this. Next, with the help of compass we'll take this measurement. We'll adjust the compass to get this much measurement, and then we'll draw one semicircle taking this point as center. This point will have to take center, and from here we'll have to draw one semicircle taking this as radius, and then this will pass through both point A and B. You can see we have drawn the semicircle which will pass through A and B. Now with the help of compass we'll take this measurement where the semicircle will cut this perpendicular line. We'll take this much measurement, we'll arrange it such a way that we can take the measurement, and from here we'll draw one arc like this to cut the number line. So wherever the arc will cut the number line, there we'll mark as P, and then here we'll write OA equals to 1 unit, and accordingly OP is equals to root over 5.6 unit. So this is the process. Thank you.